What we're going to talk about right now is solving simple matrix equations. This one is a relatively simple example. It says that the 3736 matrix is equal to negative 5 times some matrix Z plus the 711 matrix. And what I need to do is solve for the matrix Z. I need to get Z by itself. So just like solving any equation, I have an adding a matrix on one side. I need to subtract that matrix from both sides, and that'll get rid of it. Regardless of what the signs are inside the matrix, this is a plus, so I need to get rid of it by subtracting. This will cancel the matrix out, and we say 37 minus 7 is obviously 30, and 36 minus 11 is 25. And so we'll have 30, 25 is equal to a negative 5 times some matrix Z. Now we need to get rid of the negative 5, and matrix division is not really a thing. So what we need to do is multiply by the multiplicative inverse of negative 1/5, because 5 times negative 1/5 would be a positive 1, which would basically leave me just Z by itself. Of course, if I multiply the right side by negative 1/5, I got to multiply the left side as well, and then we can just use the regular distribution into the matrix, scaling the matrix by negative 1/5, essentially. Negative 1/5 times 30 is a negative 6. Negative 1/5 times 25 is a negative 5. And then we will go ahead and be able to plug that back in to test if we wanted to. So we could take the negative 6, negative 5 matrix, plug it up in here where Z is, and then distribute the 5 and add the 711, and you will see that you will get to the 3736 matrix. I'm not going to go through all those steps with you because I have other examples that I want to do. So what we're going to do is jump ahead to a slightly more difficult style, which is the ones where you have to undo matrix multiplication. Now, there is no such thing as matrix division. I cannot divide both sides by a matrix. That doesn't work because matrix division isn't actually defined. So what we need to do is, much like the 5 and the 1/5, is we need to multiply it by an inverse. So we'll call this A and we'll call this B just to make my equation a little bit easier to see. We have basically on this side matrix A times some matrix X is equal to matrix B. What I need to do is get matrix X by itself. And in order to undo the matrix multiplication here, we need to multiply A by its inverse, because when you multiply a matrix by its inverse, that'll cancel the matrix out. Of course, if we do that on the left side, we've got to do that on the right side as well. The thing is, remember that matrix multiplication is not commutative. So I cannot say B times A inverse. I have to say A inverse times B. We want to make sure that we're doing that in the right order. So this will leave me X is equal to the inverse of matrix A times matrix B. Whatever that is going to be the solution. Now you can do that in a graphing calculator relatively easy. So let's go ahead and pull up the TI-83 here. It'll open. So remember, what we're putting in is matrix A into the first one. We go over here to matrix menu, go over to edit, and the 2x2 matrix, matrix A, is going to be 0, 1, negative 1, and 3. Oops. Negative 1, and 3. And then we're going to go back to the matrix menu, go back over to edit. This time we're going to edit matrix B, and we're going to put the B matrix in there. It's still a 2x2, and so that is a negative 6, 4, negative 20, and 3. We put those two matrices into the calculator. Remember, we are doing the calculation matrix A inverse, which is the negative 1, times matrix down to B. And this will be the calculation. That would be 2, 9, negative 6, positive 4. So X is equal to 2, 9, negative 6, 4. And this is the solution to this. You could do that by hand, but it takes a lot longer to do it by hand than to do it with the calculator.